Alrighty, today we're going to talk about devices, device drivers, and Linux kernel modules. We have some questions to answer. What are devices and what are device drivers? What are Linux kernel modules and how are these concepts related? Let's start with what a device is. So, an example might be the screen, the keyboard, the mouse, the network interface, the printer. They're sort of organs of the computer, right? Pieces of the computer components that the CPU can interact with electronically, right? There's some connection between the CPU and this device, this thing that we call a device, right? That we can use. Often they are things that are sort of human interface devices, right? Something that exists in the real world, but there could be sort of virtual devices or less obvious things. Something like your RAM might even be a device on some level, right? There might be uh, ways that the kernel can interact with and change parameters of the RAM. Your hard drive also, could be a device, right? There are lots of different pieces that make up a computer, and almost all of them are devices, except for maybe the CPU. But even the CPU might be a device because there are, platform specific ways that the CPU can be tuned, configured, things like the clock speed, efficiency cores, sleeping, various other things, you know, can be configured by the kernel. The short answer is almost everything is a device. Um, but they are sort of all the pieces of the computer, and they are things that we can write code to interact with, because they are connected to the CPU. What is a device driver? Well, a device driver is precisely that code. It is the code, right, that is bridging the gap between the operating system and the hardware. It is responsible for knowing how to send electrical signals or how to tell the CPU to send electrical signals to these things that we care about, these pieces of the computer, and make them do things, right? Um, it sort of works for the operating system to allow the operating system to allow users to interact with these devices or have these devices interact with uh, the user software. We sort of have this relationship where the operating system, right, it relies on the driver um, to tell the CPU what to do to communicate with these devices. Or, if the device wants to change something, like as I move my finger on the trackpad and my mouse moves, right, there's an electrical circuitry inside of the trackpad that's measuring how my finger moves, right, and it's causing signals to be sent to the CPU, and the driver is interpreting these signals and presenting them in some way, right, that the operating system can understand, right, that no matter what the device is that's moving my mouse, whether it's a joystick or a trackpad or a mouse that sits on the table, uh, there are different ways these things move and that they interact, right? But they sort of the drivers they all present a uniform interface, right, to the operating system that it can understand. They just say the mouse went up, right, and exactly how that works is the internals of the driver, right? It's sort of a separation of concerns that the operating system worries about, where this mouse pointer is, and the driver, and dealing with events like the mouse was moved up, right, and changing the position that it stores. And making that available to other components of the system, right? And it's the driver's responsibility to interpret the physical operations, the physical details of how these things happen, um, and presenting this uniform interface, right? But it doesn't have to worry about what exactly any of these other things, right? It's a separation of concerns. So the drivers are kind of part of the operating system, but they're also kind of separate. We separate them because of this separation of concerns. We want to talk about these two different things separately. So yeah, here's a little overview of a picture here, right? There's sort of this core piece of the kernel that is not a driver in some sense, that is responsible for the most basic things, scheduling, memory management, whatever, right? And there are processes that obviously are making use of the resources, asking things like where is the mouse pointer, or what files are there on the drive. And this core kernel thing is answering these questions, but to be able to answer them, it has to work with physical devices that exist, and these drivers are connected to the kernel core, right? And they're when you list the files or whatever, one of these drivers is talking to maybe a spinning hard drive and making the head move and read from some particular sector or track, or going to some block on an SSD device, right, to read data. or as you move the mouse, whatever different things are sending these signals, right? And the details of that are between the driver and the hardware, the driver and the device. Um, but they present a uniform interface for this kernel core to sort of interpret the situation, in the hardware and make it available to our user processes. Okay, well, so what about a kernel module? What is a kernel module? Well, in the most simplest terms, a kernel module is just a snippet of code that we can add to a running kernel, right? That we can add to the Linux kernel without needing to reboot. Um, Now, these kernel modules, right, they are used for device drivers. They are used to implement device drivers. And, this makes sense because it allows us to not include all the code, right, in the thing. If we included all of the drivers, right, for any possible sort of device, the kernel, would be massive, right? So by separating these things out and literally having them separate pieces of code where we can add this code as we need, right, it's a better solution, right? It allows us to keep the kernel code and data of minimal size, right? So the actual kernel that loads into RAM is not huge. It also means that there's less of an error surface or a bug, surface that if you just don't have the code, then it can't have bugs in it, right? The only way to know that you don't have any bugs is to not have any code at all. And so if we can just leave out code that we don't need, right, then that means that the kernel is maybe more secure or less prone to errors. Um, we can customize these things as we need, right? As we add hardware at runtime, we can load the driver for that particular hardware as it's needed, instead of needing to have it all in there at once, right? And know what we're going to do. It allows us to hot plug, things in and out. And it can also be easier to develop, right? We all know the pain of having to edit the Linux kernel and recompile it, right? What if we wanted to do that for everything we wanted to change? Well, that's a pain in the butt, right? So being able to change the kernel code and data without needing to reboot is another great, advantage of device drivers. Yeah, so that's the upshot. Kernel modules allow us to write device drivers or anything else, right? Any other piece of kernel code that we wish to add in to the running kernel without rebooting it, and they allow us to implement things like device drivers that allow us to work with the hardware that we want to use.